solve my forces on y, I get sum of Fy is equal to 0, so 23 minus 16.33, 5 over square root of 34 minus 8.85, 1 over square root of 10 minus FEC equals 0. So FEC is equal to 6.2 kilonewton. Let's move to the next joint. Which will be joint C. So we are here now. Let's look at the forces acting on C. We have FCD. Then we have FCE. Then we have FCF. And then we have FBC. I'll draw FBC. Sorry. I know already FCD and FCE from the previous two joints, so my only two unknowns are FCF and FBC. Always remember that you have to follow an order where you have only two unknowns, because you only have two equations. So now we solve sum of Fy equal to 0, which means, and this angle is clearly 45 degrees because this is 3 and this is 3. So sum of F on Y means 6.2, which was the value of FC, minus FCF sine of 45 degrees equals 0, which gives me FCF equal to 8.77. And is pushing on C. Sorry, this value is for an orientation that is pulling on C. Which means that the member itself is under tension. Then if instead I solve the sum of F of the forces on X, I get 8.4 minus 8.77 cosine of 45 minus FCB equals 0, which gives me FCB equal to 2.2 kilonewtons. So we got all the forces acting on C. We can move to the next joint. Let's look at B now. On B, we have the actual force of 4 kilonewtons acting. Then we have FBC, which we just calculated to be 2.2. Then we have FBF, FBA, and that's it. Again, this angle is this angle, and it's 45 degrees because of the geometry. It's pretty easy to see. If we look at the sum, so here I want to determine FBA and FBF. Those are my two unknowns. So I solve sum of forces on X equals 0, and I get to 2.2 minus FBA cosine of 45 degrees equals 0, which gives me FBA equal to 3.1 kilonewtons. And it is pulling on my joint B, which means that the element is under tension. Then if I solve sums of forces on Y equal to 0, I obtain FBF minus 4 minus 3.11 sinus of 45 equals 0. So FBF is equal to 6.2 kilonewtons. And in this case, it is actually the opposite direction of what I drew, and you can see it because I put a positive sign in front of it, so it has to go according to the coordinates, and in the coordinates I had my Y was going upwards, so FBF is actually pushing on my joint B if it's positive, which means that the element is under compression. Now, the last joint we're going to look at is joint F. And for joint F, I'm not going to copy again the picture, but I have FCF acting on it, which was 8.77. I have FBF, which was 6.2. And I want to determine FFA. So I actually need to solve just one equation. I solve the sum of forces on X because FFA is only on X. And I obtain that 8.77 cosine of 45 this angle is 45, minus FFA equals 0. It's minus because it's going to the left, and in my coordinate system x was to the right. So I end up with FFA is equal to 6.2 kilonewtons, and is pulling is going outwards of F, so that means the element is under tension.